Alright, so we're dealing with complex numbers, and I just wanted to review a few facts about complex numbers before we get into the dividing part. So every single complex number can be written as z equals a plus bi. We know that I is the imaginary unit, I equal to the square root of -1. And we also know that a and b are just real numbers. And what we do is, we take the a and we call that the real part of z. And then we take b, we call it the imaginary part of z. So we can do many things with complex numbers. We can add them, we can subtract them, we can multiply them, and we can divide them, which is what I wanted to talk about today. So here, I have two complex numbers, and I'm dividing them. In the numerator, I have 3 plus 2i, and in the denominator, I have 4 plus 3i. And what I want to do is I want to divide the top by the bottom. So when we want to divide complex numbers, we want to make sure that we multiply the top and the bottom by the conjugate of whatever's at the bottom. So looking at the bottom of the fraction, I have 4 plus 3i. And what I want to do is I want to find the complex conjugate of 4 plus 3i. And that's going to end up being 4 minus 3i. So what I'm going to do is I'm going to multiply the top and the bottom by 4 minus 3i. So I put 4 minus 3i at the bottom, and I'm going to put 4 minus 3i at the top. So notice that the complex conjugate can be found by just changing the sign that's in between the real part and the imaginary part. And what I actually end up doing is changing the sign on the imaginary part. So it used to be a positive 3, but now it's going to be a negative 3. So now what we have to do is we have to multiply the top two numbers and we have to multiply the bottom two numbers. And the way we're going to do that is by using the FOIL method. So let's deal with the tops first. When I look at the first two numbers, I have a 3 over here and I have a 4 over here. So 3 times 4 is going to give me 12. So that's the way I start off. I multiply the first two numbers. And then what I want to do is I want to do the outer two. So now I'm looking at 3 times negative 3i. Well, 3 times negative 3i is going to give me negative 9i. The next two that I want to multiply are going to be the inside two numbers, the 2i and the positive 4. So when I multiply those, I'm going to get 8i. So I'm going to write plus 8i. And then the last thing I have to do is multiply as two parts. So I'm going to multiply this 2i times this negative 3i to get negative 6i squared. Negative 6i squared. Okay, we're going to simplify it later, but now I want to multiply the bottom two numbers. So doing exactly the same process we did at the top, we know that 4 times 4 is going to give us 16. Next, moving to the outer two, I have 4 times negative 3i. That's going to give me negative 12i. Doing the inside two numbers, I get 3i times 4. That's going to give me plus 12i. And then, looking at the last two parts, I have 3i times negative 3i. That's going to give me negative 9i squared. Negative 9i squared. Okay, so now what we can do is we can simplify the middle parts and we can simplify the last parts. So I'm going to keep the first number the same. So when I simplify this, I'm still going to have a 12 at the top, and I'm still going to have a 16 at the bottom. So I keep these two numbers the same. And then on the inside, I have these I terms that can be added together. And negative 9i plus 8i is going to give me negative 1i. So I'm going to write that as minus I. On the bottom, I have negative 12i plus 12i, and these are actually going to cancel out, right? That negative 12 plus positive 12 is going to give me 0, so I don't need to write that. The next thing I have to do is I have to take care of the I squared. And I'm going to use the fact over here that I squared is equal to negative 1. So I can rewrite this as negative 6, and I'm going to replace the I squared with a negative 1. And then at the bottom, I'm going to do the same thing. I'm going to keep the negative 9, but then I'm going to write the I squared as negative 1. Negative 1. Okay, so now I'm almost done. I just have to simplify a little bit to get my final answer. So looking over here, I have 12 minus I, 12 minus I, and then I have negative 6 times negative 1. That's going to give me a positive 6. So now looking at the bottom, I have 16, and I bring that 16 over, and I also have negative 9 times negative 1, and that's going to give me that positive 9 that I want. So that's going to change into positive 9. Okay, so now the real numbers can be added together. So at the top, I'm going to have 12 plus 6. That's going to give me 18. And then the negative I has to also come over. And then in the denominator, I have 16 plus 9, and that's going to give me 25. So 25 is going to go in the bottom. And now I'm pretty much done. I can write my answer like this because there's no more simplifying left to do. So I can leave my answer like this, or I can break it apart into two different fractions. I can also write it as 18 over 25, 18 over 25, and then negative I over 25. So I'm going to have minus 1 over 25 times I. So I could also write my answer like this, and it would also be acceptable. And I'm going to put a box around that. Okay? So, for answer, what would the real part be? Well, the real part, that would be the part that's not attached to the I, right? My real part is going to be 18 over 25. And then my imaginary part is always attached to the I. So that's going to be negative 1 over 25. And that's how you divide complex numbers. Hope that helps.